I want you to remember that virtual machines are the whole point of virtualization. They are the driving force behind any organization. They are our services. They are our applications that we roll out for the customer. They are applications we roll out for our employees. So everything we do within our virtual environment, all the configurations, all the clustering, all the advanced clustering options, all the advanced data options or the advanced networking options are meant to support virtual machines. Whenever you're in a virtual environment, sometimes you lose sight of that. I want to make sure that you remember it's all about the virtual machines. So, quick little review on what we covered in our first introduction chapter. Virtual machines are software-defined hardware. We're going to create software. That software is going to facilitate communication between the guest operating system and ESXi. This allows us a lot of flexibility because of those virtual machines allow communication directly to ESXi, which then hands off resources. Why all this abstraction? Why do that? Well, that allows us to install multiple guest operating systems on the same piece of physical hardware. Because communication is handled through the software and not directly to the hardware, we can abstract things so that multiple software communications are taking place at the same time and multiple virtual machines are receiving resources at the same time because we have that intermediary or the ESXi handling the communication. Now, this is all dependent on our hardware version. Now, the hardware version is the software version that makes up the box in which we install our guest operating system onto. So, the different version of the box determines the features. So, if we're using version 6.0, our hardware is going to communicate using this version of the software. But if we go up to version 6.5, that's a whole new version of the software that brings in new features. So you lose feature sets as you go down in hardware version. So if you created a virtual machine on ESXi version 5.5, you're using version 10, I believe. Think about that for a moment. So you're using hardware version 10. It does not matter if you vMotion that virtual machine over to a host that is running 6.5. That virtual machine will only have the feature set available to it that hardware version 10 supports. So the hardware version of virtual machines is incredibly important depending on the features you want to implement. So each hardware version aligns with the version of ESXi it was created in. So if you create a virtual machine in 6.5, your virtual machine will automatically have a hardware version of 13. If you create a virtual machine in version 6.0, it'll automatically have a hardware version of 11. Now, legacy virtual machines have lower hardware versions. Luckily for us, we can upgrade it, and we'll cover that in the upgrade chapter. But this is a definite limitation to the features you can run on certain virtual machines. Now, inside those hardware versions are actual files that make up the virtual machine itself. Let's take a moment to go through those. First off is our VMX file. Our VMX file is considered our configuration file. Whenever you alter like RAM or the vCPU, you're actually making changes to the VMX file. And the VMX file is read by the hypervisor to understand the requirements of the virtual machine. When you change the VMX file to 16 gigabytes of RAM, the hypervisor looks at that and says, this virtual machine now needs 16 gigabytes of RAM. So changes here are read by the hypervisor. Below that, we have the VMDK, and the VMDK is the storage of the virtual machine. Not physical storage, but actually the storage of the virtual machine. Think of it this way. If you think about your laptop has a hard drive in it that stores all the information from your operating system to the applications you have installed on that laptop. Your VMDK file is your hard drive for a virtual machine. That's what it is. So this VMDK file contains your guest operating system. It contains all your applications that you're running. So this is an incredibly important file. In fact, the VMX and VMDK file are the two most important files for a virtual machine. Anything we have below that, the NVRAM, the vSwap, and the log, all those files can be recreated from these two files, the VMX and VMDK. And I'll actually show you that a little later. Now, the NVRAM contains our BIOS or EFI. So depending on what you use, either BIOS or EFI, that's contained, all those configurations are in your NVRAM. We have our vSwap file. This holds a swap file for the creation of the virtual machine. This isn't just any swap file. This is the swap file for the creation of the virtual machine. Very important you remember that. This actually disappears when you power off a virtual machine. This log file right here contains all the logs for the virtual machine that you might need for troubleshooting on the hardware itself. This is not the guest operating system log files, but the log files for the virtual machine. Now, our creation process for a virtual machine is pretty straightforward. We're going to choose a compute resource object in our environment from the navigation pane. Once we do that, once we select who's going to be our compute resource, we can right-click on that object and then click Create a Virtual Machine. Now, there's several types of creation. There's new VM, and that would be creating a virtual machine from scratch. From a template, which would be using a template that we created from another virtual machine to create the new virtual machine. That would include its operating system, any configurations that have been put in place. And then you take a template of that and you can deploy that virtual machine over and over again with the same settings, the same operating systems, all the same configurations that you've already put in place. We have the ability to clone, which is to make an exact replica of the virtual machine we have on hand, and convert a template to a virtual machine. We would use that basically when we've created a template. Once we've created the template and we need to make a change to that template, let's say I created a template for Ubuntu. And there's a new version of Ubuntu or a new patch that comes out for Ubuntu that I now want to include in my template so all my virtual machines going forward have that particular patch. What I would do is I would convert that template to a virtual machine, apply the patch, and then convert it back to a template. So at that point, if I use that template to deploy virtual machines in the future, they would already include the patch. Next up, after we've selected our creation type, we're going to take a breath. No, after we've selected our creation type, we're going to select the file location. Now, it's important to choose the file location based on the tier of the application you're using. So make sure you have the right reads and write performance needs you want. Make sure that data store that you're putting the file on has the correct amount of space. Everything you need for storage needs to be in place, okay? Choose your VM file location. Most likely it's going to match to a tier in your environment. And then we're going to choose the guest operating system for the virtual machine. Now, that's important in this environment because VMware has gone through the trouble of putting the minimum requirements for a guest operating system baked inside the creation process. So if you chose Windows as your guest operating system and then the version, it will automatically choose the specs for you, the number of processors, the amount of RAM, and the hard drive space. Now, because it's going to do that automatically, they don't know the type of application you're going to be running on that virtual machine. So you can customize it if necessary, add more virtual CPUs or RAM as well. After we've done that, this is basically from here up is creating that software-defined hardware box. After that, we're going to start the virtual machine and install the guest OS on top of that software-defined hardware box, and then our VM tools. That would complete the VM creation process. Now here I've taken the liberty of showing you a screenshot. We're actually going to do a demonstration at the end of this. So I've given you the creation process. Here you can see the create new virtual machine. Deploy from a template is probably what you're going to use 80 to 90% of the time. This is going to be more widely used because it cuts administrative time, right? You're going to create a virtual machine. You're going to put your operating system on it. You're going to harden the operating system. You're going to follow organizational policies. And then you have a base operating system on which you can install different applications to. Once you've done that, once you've created that base operating system, go ahead and convert it to a template. So now you have a Windows template. And anytime you're going to roll out a service or application that requires a Windows operating system, you can just deploy from the template instead of every single time you want to deploy a service from Windows, going through the entire creation process over and over again, where you create the virtual machine, you install the guest operating system, you harden the guest operating system, and then finally install the application. It's like a cheat sheet using templates. This allows you to jump directly to installing the application. So really highly useful and cuts down on administrative time quite a bit. Below you can see that we have the cloning options. We'll get into that a little later. And then convert template to a virtual machine, which I already explained is all about making changes to your template. So when we talk about the hardware, I said we can customize settings. Well, one of the customization options for settings is our virtual CPUs, our RAM, and our general configuration. So let's take a moment to discuss our virtual CPUs. It cannot be more than the host logical processors. So if I have two physical sockets, each one of those physical sockets contains a 4-core processor. How many logical processors do I have? Well, if I'm not hyper-threading, let me take off my shoes and do the math here, I would have 8 logical processors, right? If I am hyper-threading, if I have the ability to hyper-thread, that would be 16 logical processors. This means that no virtual machine I create can have more than 8 or 16 virtual processors, depending on whether or not I'm hyper-threading. We also cannot exceed the number of physical sockets. So let's review. I have 2 physical sockets. Each socket has a 4-core processor in it. So even though I have 8 or even 16 if I'm hyper-threading, 16 logical processors, I cannot tell my virtual machine that I have 4 physical sockets with 4 processors each, with 4 cores each. I can't tell it that. And the reason is that will create contention. When we have contention in our environments, what this means is we're struggling for resources. In this case, the virtual machine would believe that it has 4 sockets, 4 different avenues for processing, and it can send out 4 processing chunks at a time to 4 physical sockets. That's not the case at all. I only have 2 physical sockets. The rest are cores. So what I need to do is put this down to 2 sockets, change this to 2, and then I could even put up to 8 processors per socket. 8 cores. And that's perfectly fine because I no longer believe I have those avenues to send those instructions down. If there is contention, let's say there is contention, even in this scenario. Let's say I have multiple virtual machines trying to access these 2 sockets at a time. How does the ESXi handle that? Well, it handles it by creating little time slices. And these time slices are then handed out to virtual machines in the order in which it came in, depending on shares, how our shares are created. So this allows us to, although we don't have enough processing to go around, this allows us a little bit of a reprieve. We create a line. Not great for virtual machines themselves or the applications running on them. We're going to get bogged down. It's going to be a problem. But at least the world doesn't implode, right? At least everything doesn't shut down on us. So be very careful. If you over provision the number of sockets, you're automatically creating contention for one virtual machine. That's a bad deal. So don't do that. Follow the number of sockets. I'll show you how to do that when we get into the actual demonstration. In virtual CPUs, we have the ability to hot add, so we could add CPUs as required. That setting works for some guest operating systems, not so much for others. So make sure you test it in a lab for your operating system to make sure it works well for you. Hot add settings is you have to select it when you initially, before you power on the virtual machine, or if the virtual machine is powered off. You cannot, this is not one of those settings you can add while a virtual machine is running. It will be grayed out. It won't even allow you to do it. When we're talking about RAM for a virtual machine, we have up to 6 terabytes of RAM per virtual machine. That's a large number. If you've ever used that much RAM in a virtual machine, I'd like to know. Usually VMware has gone ridiculous with these numbers. Even the older versions were 2 terabyte or something crazy as well. So those numbers are usually, they try and go as high as they possibly can for the amount of RAM you can allocate to a virtual machine. And again, just like we did with vCPU, we have the hot add setting for RAM. And once again, this has to be turned on or off when the virtual machine is powered off. Now, some of our general settings, like adding new hardware or features, adding new hardware to a virtual machine, they have to be sometimes done through when the virtual machine itself is powered off. So make sure you're aware if you're going to add hard disk space, you're going to add another hard drive, you may have to power off your virtual machine for your guest operating system to recognize it. So, just fool around with it a little bit in your environment to make sure that the things you can and can't do. Also, in general, we've added Secure Boot. This is pretty cool. This is securing from specific software, what can boot and not boot from. We have NVMe, and we have enhanced pass-through services. We'll go through the pass-through process a little bit. Pretty cool feature. Allows direct access to your PCI devices or your PCIe devices in your environment. So that's not all we have access to for our settings. There are other options. We can change a VM name. We can enable our remote console. We can adjust our VM tool behavior. Remember, VM tools allows for a closer communication between our guest operating system and ESXi itself. I highly recommend VM tools. We'll talk more about it later, but highly recommended. Power management options for a virtual machine. We also have the ability to change our boot options and our delay in boot. Useful if in your nested environment, if you're trying to install things and record. Boot options allows us the ability to put a little space in there before we actually boot our guest operating system, among other things, and we'll go through that. Advanced features like acceleration, debugging, the swap location of a virtual machine, configuration parameters and latency, all available there. And then our fiber channel configuration for the virtual machine is also one of those things that we can change. Now, let's take a breath. All right. So one of our configuration options that we talked about was templates. And like I said, this is what we're trying to create with a template is a base installation. So you create a virtual machine, you put in your guest operating system, you configure it to the nines and to your organizational policy. Now you're going to take that and you're going to convert that to a template. And this template is going to be the base installation for that guest operating system. So if I'm running Windows, oops, let me get rid of that. If I'm running Windows, I'll have a Windows template, but I also might have a Linux template or a type of Linux, maybe Ubuntu specifically. And the reason is I have different applications that run on different operating systems. So I have multiple templates in my environment, one for each deployment. I might even have a deployment specifically for Windows for just security. Or maybe a specific location. This is my Windows template for my branch office. So that you can have configurations that are specific to that branch office already baked into that Windows configuration, already baked into the template. Then we convert to a VM, and then we deploy from that VM. Saves us all that administrative time. So really, really important feature here. It allows us a lot of efficiency in the deployment of those virtual machines. Really great feature. Like I said, you're going to use this 80 to 90% of the time for your VM deployments. It really is your go-to deployment feature. The other type of deployment we talked about just a tiny bit was cloning. Cloning makes us take an exact replica of a virtual machine. Now, if we think about that in networking terms, that's a little dangerous, right? We have MAC addresses, we have network IP addresses that are now duplicated. That's going to kill communication. We no longer will be able to communicate across our network. The thing is, this is excellent for testing though. If I have a problem with a specific virtual machine and I'm not quite sure what's going on with it, I might clone that virtual machine and drag it into my lab environment to take a look and see what's going wrong with it. Cloning is also used to create those templates we talked about. Now the process is a little different. We don't just clone and we have a template. It's a specific process called cloning to a template. And it makes minor changes so that we're scrubbing out some of this MAC address information and networking information, and even our fully qualified domain names. So lots of cool features here in the deployment of virtual machines. It allows us several different options, from cloning to templates to deploying from a template to making changes to a template. All of those really important, and we are going to go through a demonstration in our next lesson on all these different features and where to find them.